So in this lecture we will be seeing some extra numericals on simply supported beam subjected to point load. Okay, so in the previous videos we have seen all the basic concepts that are required to solve these problems. If you have not seen that, you should see it and then come to this lecture. Okay, now if you have seen all the videos, then I would recommend that you first try to solve the problem on your own. Okay, I will write the question, you pause the video and then solve it by your own. Don't look the video. See up to what extent you are able to solve. What are the problems that you are getting? Let's say you are not getting what are the conditions of equilibrium. Then after that you find out what are the problems or what are the difficulties you are getting, and then you check the answer from this video. Okay, you can get the problems. Basically I will tell you, you will get the problems while applying the third condition of equilibrium, that is sigma m is equal to 0. Which force to take clockwise, which force we should take it as moment of force, we should take it as anti-clockwise. So there you can get the problem, but up to that point you first try to solve the problem on your own. You know the steps now. Draw the reaction diagram, then apply the conditions of equilibrium. These are the only two steps. Listen, the structure subject is very easy. You just have to follow the systematic procedure. Okay, if you try to learn this, if you try to learn how to solve the problem, then you are not going to excel in this subject. You have to gradually improve in this subject. You practice, identify where you are lacking, and then work on your problems. That will lead to the success in this subject. Okay, so we'll start now. So this is the first problem. A simply supported beam of span 5 meter is subjected to point load of 20 kilonewton at center. Find the reactions of beam. So we have to find the reactions of beam. So you can pause the video and you can solve on your own. So first we will draw the beam. So this is the beam. Now in this beam it is simply supported. That means this support is an hinge support and this is a roller support. The span of the beam is 5 meter. That means this length is 5 meter, and the point load value, the value of point load, it is 20 kilonewton. 20 kilonewton, and it is present at the center. It is there, that means it is 2.5 and this is also 2.5 meter. So now first we'll draw the reaction diagram. Now I will be drawing the reactions here only. Up to now we were drawing in a separate diagram, but from now onwards I will be drawing it here only. So this is point A and this is point B. So at point A, the type of support which is present there is hinge support. Hinge support has two reactions, one in vertical, one in horizontal direction, and roller support has one reaction, one in vertical direction. We'll name this. This is VA, this is VB, and this is HA. Okay, so these are the three reactions which are present. We have to find out these three values, HA, VA, and VB. So how to find out? Applying the first superpower. What is the superpower that we have? The first one, conditions of equilibrium. So sigma fx is equal to 0. Sigma fx is equal to 0. In horizontal direction, there is only one force, HA. That means HA, this is equal to 0. So first we have got, that is HA. Second condition, sigma fy is equal to 0. Sigma fy is equal to 0. So this is positive x direction, positive y direction, and negative y direction. So see the force VA and VB, they are going on the upside, that means positive y direction. So it will be VA plus VB, and this 20 is going in negative y direction, so minus 20, this is equal to 0. If we solve, we'll get VA plus VB is equal to 20. Third condition, sigma m is equal to 0. That is, moment of all the forces about one point is equal to 0. So we'll take sigma ma is equal to 0. Now what is the moment of HA? HA into 0. What is the moment of VB? VA into 0. What is the moment of 20 kilonewton force? We all know the moment formula is force into distance. The force value is 20. Distance value is 20 distance from point A. This is 2.5. 20 into 2.5, and the last one is VB into 5. Okay. Now the directions we will assume clockwise direction positive. Clockwise direction positive. Now to identify the direction of 20, remove all the other forces HA, VA and VB. If you see, the beam will be rotating in this direction. So this is a clockwise direction, so we'll take it as positive. Similarly, the direction of VB will be anti-clockwise direction, so we'll take it as negative. This is equal to 0. So if we solve this, we'll get 20 into 2.5 is equal to VB into 5. So VB is equal to 20 into 2.5 divided by 5. So 2.5 ones are 2.5 twos are 20 divided by 2. This is equal to 10. So VB value is 10. VB value is 10. Substitute this VB in the second equation. So VA plus VB is equal to 20. This means VA plus 10 is equal to 20. VA is equal to 20 minus 10, that is 10. So we'll write the final answers. What are all the reactions here? VA value is 10, VB value is 10 and HA value is 0. So these are the three reactions for simply supported beam. Now let's take another problem. A simply supported beam of span 20 meter. It is subjected to point load of 50 kN at the center. Find the reactions. So same method. First draw the beam, reaction diagram and apply conditions of equilibrium. So try to solve on your own and then look at this solution. Okay, you pause the video. Okay, a simply supported beam, one end hinge, another end roller. The span of the beam is 20 meter. The value of point load is 50 kilonewton. It is present at center. That means this is 10, this is 10. This is point A, this is point B. How many reactions are present at point A? Two reactions, vertical and horizontal. At point B, only vertical. So we have to find out these three reactions. So we'll apply our superpower, that is applying conditions of equilibrium. Sigma fx is equal to 0. So in x direction only HA is there. So HA is equal to 0. Second condition, sigma fy is equal to 0. That means VA plus VB minus 50 is equal to 0. So VA plus VB, this is equal to 50. Third condition is sigma MA is equal to 0. So HA into 0, VA into 0 plus 50 into 10. It is plus because clockwise direction. So clockwise is positive, and minus VB into 20. This is equal to 0. So 500 minus 20 VB is 0. VB is 500 divided by 20. So this is 50 divided by 2, 25. So VB is 25. VA plus VB is 50. So VA is also 25. So this is 25, 25, and this is 0. Okay. So now we have solved all the three problems. Now just pay attention here. For a simply supported beam subjected to point load at center, okay, if a point load is subjected at center, then there are two things which you have to see here. The first thing that you have to observe, that the value of HA is coming as 0. Okay, the value of HA is coming as 0. If you see this problem also, HA is 0. In this problem also, HA is 0. That means for all the vertical loads, this HA value will be 0. If there is some incline loading like this on the beam, okay, if there is some incline loading, then only the value of HA will come, otherwise the value will be 0. Second point that you have to note is, for point load at center, if the value of point load is P, then the reactions VA and VB, what is the value? It is P by 2 and P by 2. That means if 50 kilonewton it is acting at center, then VA is 25 and VB is 25. If this is P, then this is P by 2 and this is also P by 2. In the previous problem also you can see 20 kilonewton is acting at center. So if this is P, what is VA? P by 2, 20 by 2, 20 by 2. So for any simply supported beam subjected to point load at center, what are the reactions? The reactions are P by 2 and P by 2. So you should remember this directly now. In next class we will be seeing an eccentric load condition.